Hello, everybody. Thank you for being here. I see many familiar faces here today, and that makes me happy. But for some of you who don't know us yet, just let us introduce ourselves a bit. So I am Cristina from eSolutions. I'm a manager at Core. But since I'm very passionate about data management and data analysis, I have been handling our big data projects for several years now. And I'm here today to share with you some of my experience. Lucian, can you tell us something about yourself?
Hi, I am head of data engineering at eSolutions, where I lead our big data projects and support our team to use the last technology and best practice to build scalable and robust data solutions.
Thank you, Lucian. He is my partner in crime day to day at the office. So now, as you may have intuited, our presentation will handle the two big players in any big data project, meaning the business side and the technical side. I promise the technical will be much longer, since this is, I think, what you're all interested about. So let's get going. Usually, companies get to the idea of becoming data-driven and implementing a big data project when facing some challenges. So I've tried to summarize some of the challenges that I've encountered during my experience. So the first one will be, of course, handling large volumes of data, as companies are now drowning in all sorts of data from all sorts of systems, IoT devices, websites, back office system, and so on and so forth. And it becomes harder and harder to manage all this volume in an efficient manner. Another big challenge is integrating diverse data sources. Since we are all in our companies using multiple systems, of course, they all store data in a different way, and that can be a challenge. Ensuring data quality and consistency is also very important, since with a poor data quality, you risk of having poorly data decisions made, and this is exactly the opposite effect that we want to obtain when implementing a big data platform. Real-time processing and analytics are starting to get even more important nowadays, and having access to manage this can offer you a huge leverage over your competition, so you don't have any other choice than to be able to handle real-time data and analytics nowadays. Also enabling advanced analytics and machine learning algorithms that can help you forecast trends and quickly adapt your strategies in order to respond to the market. And last but not least, of course, optimizing your operations and reducing your costs, since now with a big data platform, you will have the possibility to manage your storage, your consumptions, and managing and optimizing and reducing your costs as well. So now that we've seen the most popular, so to speak, challenges when considering a big data platform, let's see what type of roadmap will you face if you decide to implement such a project. Well, the first one will be, of course, gathering your business requirements. And this is a particularly interesting and important step, since usually in this phase, companies are really starting to identify their pain points in their data, and also gaining a business sponsor. If you are a tech team, you will later need a business sponsor that will validate the return of your implementation. Next, you will probably want to select the appropriate tool list for you and build an implementation plan. Afterwards, of course, starting to set up your infrastructure and configuring it. And then you can start implementing, testing, and deploying your first data pipelines and expose to consumption your new data sets, your new data marts for your business. After you've had, let's say, your first data set ready to be exposed, you can then start and continue implementing new use cases for your business to consume. So now that we've seen just a bit the business side, I will hand over the mic to Lucian that will tell us more about how we approach these projects from a technical point of view.
Yeah, thank you. Let's explore the technical details of a modern data platform. Nowadays, we are interacting with different data types let's see if I can use, no? I will show you that. We can interact with different data types that are generated by internal applications, also by external systems. And to ingest all those data and extract the values from them to improve our business, a data platform should cover 6 layers, such ingest, data storage and processing, data transformation and modeling, advanced analytics and visualizations, data serving, and of course the observability. Regarding of data ingest, here we have 2 strategies to choose of. We can use data acquisitions. That means we use middleware tools to bring data in our platform. And the second strategy is data collections, which means we provide streaming and batching interface to receive data in our platform. The data storage and processing is the main layer of our modern data platform, where we store all our data and keep them for the long period of time. By using processing, we ensure our data are clean, trusted, well documented, and accessible. In this way, we avoid losing control of our data, and our data lake doesn't become a data swamp. The data transformations and the modeling is the place where we transform our raw data in meaningful format, ready to be used. The advanced analytics and the visualizations is about extracting value from our data and enabling data-driven decisions. Data serving is the last layer of end-to-end data solutions, where we make our data available for consumptions. But let's not forget the observability, the important part of any systems, which help us to monitoring our infrastructure, also our data pipelines. But observability also help us to understand and discover our data. As you can see, the main goal of our modern data platform is to bring trust in our data using a scalable, of course, scalable solutions. Okay, until now we have seen some functional requirements of a modern data platform, but let's take a look also to the main non-functional requirements that we have to have in our platforms. The platform should be handle large volume of data, also high velocity workloads. And for that, we have to cover with the performance and take care of cost efficient. Regarding of portability, our platform should operate on different environments. In this way, we avoid vendor locked. In case of failure, our services should automatically restart or migrate to available nodes. And also, our services should automatically scale up and down based on the CPU and the memory usage, but also based on the traffic spikes. To cover all of this, we should have a platform, we should use a platform based on Kubernetes.
Yes, so now me and Lucian have tried to identify the most popular use cases that we've encountered during our business and try to tell you a bit about them. So the first one that we've identified is the need for advanced analytics. So for instance, if you are a healthcare provider and you may want to have information from the electronic health records, from your lab systems, and even from the billing software, then you need to have a way in which you can handle all of this information so that you can extract relevant information. Another popular use case is building smart operational processes. For instance, if you have a manufacturing company, you will want to have information directly from the production line as fast as possible. You want to identify bottlenecks, you want to optimize your productivity, and so on and so forth. And last but not least, large organizations. Large organizations are a bit of a different use case, since large organizations usually have a more complex data pool and data environment, and a more complex organizational chart, which means complex data responsibility and management and communication. So now, Lucian, can you tell us a bit how we can handle these types of use cases and scenarios?
Of course. To cover all those challenges, we have built KubeLake, a versatile and modular data platform on Kubernetes, based on open source tools and frameworks. When we choose the technology stack, we took into considerations the adoptions, the community support, and the performance. As you can see in this blueprint, our platform is designed by layers, and each layer covers a specific context. Starting from infrastructure, where we have Kubernetes, of course, KubeLake is well integrated with Kubesol, another open source Kubernetes distributions, our open source Kubernetes distributions. And for monitoring, we have Grafana, Loki, and Prometheus. And for security, we use Keycloak as a single sign-on. Regarding of data lifecycle, we have data integrations, where we use NiFi to bring data in our platform. Because NiFi is agnostic tool and guarantees the data delivery, we can use NiFi also to push data to external systems. On the storage, we use Postgres as a traditional database, Minio, which is an object storage for data lake, ClickHouse, which is a columnar database for warehouse, and Kafka, of course, as a message storage. On data lake, we support Delta Lake and Iceberg table formats, and Hive as a meta data repository. For processing, we have, of course, Spark for data processing and Airflow for pipeline orchestrations. Because we are in Kubernetes environment, we can create also clusterless process jobs using Kafka streams, dbt, Python with pandas or NumPy, and so on. Zookeeper and Unicorn are for coordinating and resource scheduling, especially for our processing jobs. On the explorations and analytics layer, we have Zeppelin, which is a collaborative notebook system that supports multiple technologies like Spark, Python, Scala, Markdown, SQL, and so on. And for machine learning, you can use Spark MLlib. For data catalog and discovery, we are using open metadata, which help us to manage and understand our data. For data serving, right now we have Trino, which is a massive parallel processing SQL engine that can act as a self-service access layer, over JDBC or ODBC. Trino also provides a RESTful API, but is designed for SQL query, and we intend in the next release to add another API for interact the data more close to the RESTful concepts. Of course, for data visualizations, we are using Superset, which provide a rich offset of BI features, perfect for technical and non-technical users. As I said, the platform is a modular one. That means we can install only the component that we need, and we are free to use other components instead of what we have. Okay. Now, let's take each use case and see how Kubernetes help us to implement them. The first use case was advanced analytics, where we want to collect data from multiple data sources using different strategies, such as SQL query, change data capture, files from CFTP, data from streaming systems, and so on. Once you have those data in our platform, we want to process them and extract the useful information to improve our business. For data ingest, in this case, we can use NiFi, which can interact with multiple data sources. And because it's an agnostic data tool, as I said, we can ingest all kinds of data. Those data will be saved in our data lake in the landing zone, which is a Minio bucket. And using Spark, we apply data quality checks and transform those raw data into table format, like Delta Lake. Because we transform the data our data in table format, we now have direct access to the raw data. The warehouse is covered by ClickHouse, which is a columnar database designed for real-time analytics and complex queries. To access those data, we use Trino, which is able to query data from both data sources, from our data lake, also from our warehouse. Trino also is capable to auto-scaling based on the consumptions. As you can see, the platform provides all the tools that you need to create an end-to-end data pipeline. But let's take also the second use case, which is an edge computing model, where we are focused more on operations data rather than data decisions. Sorry. Unlike the traditional approach, where we process data in the centralized ecosystem, on edge computing, we want to process data close to the data source. The main challenge here is to optimize and orchestrate a decentralized system. Therefore, we need solutions to manage all those edge nodes in an automatic way. For that, we use NiFi as edge nodes and NiFi as computing logic manager. The communication between the edge nodes and the cluster is done over two interfaces. One to push the computing logic to the nodes, and one to receive data in our platform. We receive two types of data. We receive health check data and also business data. Using health check data and Grafana, we can monitoring our edge nodes and define alerts if something doesn't work as we expected. Our business nodes will be saved in our data lake as raw nodes, and we use Spark to process them. Then the result, we can save the result in Postgres. In this way, we can consume those results by an external applications, for example, a mobile applications. Of course, the results can be used also by business users using Superset, and in this way, they can create analytics at each plant level, but also they can create global reports at a global level. Using this use case, this scalable approach and distributed system, we can manage 1,000 to million edge nodes with different computing flows. Okay. The final use case is for the large organizations, where the biggest challenge is the gap between the domain experts and the data interpretations. Usually, we have two teams, one for applications and one team for data processing. This approach creates a lot of cross-communication and bottlenecks. Kubernetes provides, to avoid this and resolve these issues, provide a domain-specific workspace where each domain team has full ownership. They control which components should be installed, the resource allocated to each component. Also, they have control over their pipelines. In this use case, we have used the data collection strategy to ingest data in our platform, because the team that generates the data also are in charge of the platform, and it's much easier for them to push the data in our platform instead of managing a new components. Then we use Spark to process those data and save them to ClickHouse or Delta Lake, depends on each domain implementations. To access those data, each domain has his own Trino instance. Using Trino, we can have access to our data, but we can also access the data from others' domain that was published in our catalog. That means each domain team decides which data and where should be published. By published data doesn't mean to copy data from one workspace to another, only define the connections and the security policy for them. As I said, each domain can install the component that they need. In this use case, the first team, they install also the superset, which is connected to the Trino. And because in that Trino we have data published from both domains, we are now able to create cross-domain reports. As you can see, the platform is very flexible and empower each domain team to manage their ecosystem. Yeah. So far, I show you how the Kubernetes can help us to improve our business. But as we all know, adding a new platform, a new tool, requires time to manage and maintaining it. Our platform is designed to minimize this effort. By using standard tools like Ansible, Helm, and Kubernetes Operator, we ensure that maintenance efforts remain low, and it's easy to onboarding new team members. Also, the platform has amazing monitoring tools like Prometheus, Loki, and Grafana, which allows us to see what is going on in our system. Also, we can proactively identify and fix issues. The big advantage that we are in Kubernetes is that it's enabling Streamlabs update. This ensures that our platform remains operational during the updates processing. The result is a robust scalable and flexible data platform that can grow without trade-offs.
Thank you, Lucian. Now that we've seen our business premises and challenges and also the technical implementations, let's try to review a bit the benefits that such a project can bring us. So the first one is, of course, enhanced decision-making, because companies can now make informed decisions on real-time data, comprehensive insights, and accurate data. Another important benefit is the operational efficiency. Because having a big data platform gives you now the possibility to automate and eliminate some manual processes. Of course, scalability and flexibility. This is a requirement for any modern big data platform. It should be able to handle your growing volumes of data and keep up with them without producing performance degradation. Improved customer insights. Now you can better build your forecasts, identify your customer behavior, and be able to quickly react to the market and stay competitive. Of course, cost savings, since now you have a smart way of managing your storage and your processing costs, so now you can reduce them. And last but not least, data governance and security, since such a platform usually comes with embedded data policies, and you can automatically comply to any regulations and avoid data breaches. So that being said, let us tell you a bit about our future plans in KubeLake. So for our next releases, we plan to support AutoML. For the streaming processing, now we use Kafka streams and Spark, but we plan to add support for Flink as well, and great expectations for data quality. So if you want to see KubeLake in action, we also have a workshop right after our lunch break, and you can register there to see how it really works. And this is it from us for today. Thank you very much for being here, and we remain at your disposal. Thank you.
Thank you, Cristina, Lucian. Wonderful mix of business and technical. Let's see if we have some questions from the audience. I forgot my mic there. Let's see some raised hands. No? Okay. I have a question. Because you were talking about optimizing costs within a company and offering access to valuable insights that could basically grow the business. Have you managed to figure out like a percentage of wins a company would get by implementing your solution into their process?
The answer is very fast and quick. No, because our solution only gives you the instrument in which you can handle and scale as much as you want. As for reducing costs, you do have the tools to manage yourselves how much you invest in storage and processing. So this is one way where you can really handle your costs. And of course, if you have all this data, as I said, you can reduce some manual efforts, and this also brings back some resources back to the company.
Thank you. Let's see. Any questions? Yeah.
Hi. I saw that there are a lot of components. How fast can you install it?
Lucian.
Maximum 1 day.
Like that.
Thank you. Anyone else? Yeah. Maria.
Hello. You mentioned that you'd like to implement Flink in one of your next iterations. Is that an alternative to Spark or to complement it?
As alternative.
What are the grounds, or what are the things that motivated you to go this way?
Do you already have a platform and you want to migrate to Kubernetes, and you have legacy jobs using Flink, if I can say legacy. And for that we support. We want to support also Flink.
All right. Thank you.
Thank you. Anyone else?
It's lunchtime. Everybody's hungry, but we'll be here the whole day if anything pops up to your mind
And
later.
as Cristina said, you can also find them at the workshop and interact with CubeLake yourselves. Thank you very much. Another big
Thank you.
round of applause.